When you go to the PhET site, this will be the lab that you are doing on your Chromebooks or other devices at home. It's HTML5. There's part of it, this Basics Lab, which is not available, but is available on this older Java version. So that's what I'm going to do. When I click here, it looks like this. I've actually already downloaded it, so it's going to look like this when it pops up. So I'm going to try to get the settings the same as I would otherwise. So there's an introduction here, but there's actually a part with dielectric. There's also a part with multiple capacitors, but over here is what I'm going to do. All the checkboxes, electric field lines, capacitance, plate top charge, stored energy, voltmeter. I'm going to go down here and up here. So I can go down here on this wire, be across that. And custom, and we're going to select a dielectric constant of 2. There we go. Show all charges. Show that's different than showing excess charges, by the way. So I'm going to move the dielectric in and out of the electric field. So I have something like this. I am going to turn the battery on. I'm going to turn it on to 1.5 volts. That's something I forgot to mention. So this is bigger than it should. Okay, we're going to zoom that out. Well, that would be nice if we could zoom that in. I want to get that again. That's weird. Oh well, whatever. So I've got the electric field lines in here. Obviously, if I put the battery polarity the other way, the field lines would be pointing up. So this is kind of a nice way to show that. And I'm going to put this in. Move it out. And put it in. And move it out. So notice the capacitance is increasing. Put that on the same scale there. And this also, I've got to reduce that. So stored energy increases, the charge increases, the capacitance increases. And when you look at this, the reason is if this is a material, if you recall what's happening here, and you can barely see it in there where the negative charges and are aligning. So although this is an insulator, the materials in here are aligned, so there's negatives closer to the top, positives closer to the bottom. That allows more charges to be packed in for the same potential difference. So this hasn't changed at all. Okay. I'm going to change to a custom material, so I'm going to pull this out. I'm going to change it up to 5. So the material is different now. If I push this in, notice how many more charges go up here. So the electric field strength is how close these lines are to each other. If you look at that, that isn't changing. Now that might seem weird because it's like, look at all those positives on the top. Yeah, but there's a net electric field pointing the opposite way in here. See the little negative above the little positive? So if you're got the same potential difference across here, which we do, it stayed at 1.5 volts, and you've got the same distance between these two, the net electric field is going to be the same. You'll be able to hold a lot more charges on these plates because of the dielectric. Now, if we only showed the excess charge here, that in some ways is a little bit better. So if you notice this here, the excess charges in the dielectric, there's a bunch of negatives at the top, positives at the bottom. And so those cause a back electrical field, which you can't see, that opposes this electrical field that's down. And so that's why the net field stays the same. And so if I change this down to a 2 again, now there's fewer charges up there up top, fewer negatives at the top of this. Okay, so I think that should do it.